Hey folks, this is Major Jones here to talk to you about the completed LC-3. This is kind of our summary lesson to talk about the higher level perspective of the LC-3, and it's primarily something my brain likes to do when it sort of gets to the end of a big project like this, is sort of take a step back and try to view this thing in its entirety. So I'm going to give you sort of put some of that information together so we can kind of take a step back and see the LC-3 in its entirety. And then additionally, I want to take this opportunity to kind of reinforce the distinctions between a computer's architecture and its organization. So while we're doing this, I want you to keep in mind kind of a couple of things. I'll make some callbacks, all the way back to Unit 1. I want you to remember that the LC-3, at its heart, it's still this von Neumann machine, right? We're going to see a very complex data path in a second, but all that boils down to are just these 5 units: our control unit, our processing unit, our memory, our inputs, and our outputs. And you can recall also the little man computer. This is sort of a simplified version of the LC-3, or just kind of a von Neumann computer in general. And even though this diagram right here, which is our final data path we looked at, even though there's a lot going on, it is, at its heart, just a more complex version of a unique type of machine called the computer. And the thing that makes this computer, if you recall from, or if you did the lesson on Turing machines, right, was the fact that we can sort of program this thing, to solve any number of problems. At its heart, it's just this von Neumann machine, right, that we've programmed to be able to execute a couple of useful instructions. Those instructions, you can see, here, adds and ands and loads and stores. I mean, nothing too complex, but we've programmed this thing so that as long as we can define a problem using those instructions in the LC-3, we can we can execute that on our computer and arrive at an answer. And so just like the universal Turing machine, is said to be a computer because it has this sort of generic framework to be able to execute any type of program and solve basically any type of problem. Our LC-3 at its heart is just that, right? All we've done is orchestrate this device which can implement our instructions, and as long as we can take whatever problem we want and boil it down into some series of those instructions, then we can solve that problem with our LC-3. And ultimately, what we know, if you've done the Turing machine lesson, is that any problem that can be solved, that's computable, as Alan Turing would say, is solvable by the LC-3 by virtue of sort of those instructions. So I just don't want us to get kind of lost in the weeds here, right? This is still a von Neumann machine. But if we are kind of trying to see this in its entirety, right? This right here, this block diagram is the entirety of the actual hardware that makes up our LC-3, and the big parts right here, right, are the control logic. We've got a big chunk here that deals with the processing of our data, a big chunk here for our memory, and some connections to our inputs and outputs. This control logic, this block that sort of orchestrates the whole LC-3, is implemented by a microprogrammed finite state machine with a sequencer. So you recall from that lesson that the inputs to this thing include not just sort of the current state of what's being executed, but a couple of key signals that indicate whether or not we have an interrupt, or there's been an access control violation or something like that. And together, these help us figure out where in our memory, where in our control store, the LC-3 needs to look to find the next state and what control signals it's sending out. And that control store is implementing effectively these 2 state diagrams. This one on the left was the basic one that implements our instructions, our simple set of instructions, and the one on the right is the one that implements the ability to execute the trap instruction and then return from interrupt instruction, as well as handle interrupts and our 3 different types of exceptions. And so these state diagrams are encoded here in the control store, and and the outputs of that control store, these 52 signals, include not just sort of 10 bits to decide what the current state is and what we're branching on next, but also these 42 control signals. These are all the control signals that go to each of the devices here in the data path to set whether a device is allowed to put something on the processor bus, or a register is being loaded with a piece of data, or which of the inputs to these multiplexers need to go to the outputs. These are all encoded in the 42 control signals that are in the control store here. And so this together, right? This is the LC-3, which to me is kind of cool. And like I said, I want to sort of differentiate that also between the architecture, right? So again, to kind of call back to Unit 1, our pyramid of abstraction here, there's an interesting distinction between these two layers, between the architecture layer and the organization layer. And so what we've just looked at here is what we would call the organization. It's the actual implementation of the LC-3. We might also call this the microarchitecture. And kind of equivalently, right, Appendix C almost entirely deals with our organization, the actual implementation. But it's interesting to me, at least, to note that that's separate from what we would call the architecture, the instruction set architecture, right? How many memories are in our LC-3? How many registers are in the LC-3? What's the memory size? Which instructions are the ones we execute? Additionally, what does our memory map kind of look like? In what ways does the LC-3 handle trap instructions and interrupt instructions? These are all kind of the purview of Appendix A. And that, of course, is our architecture. And what's interesting to me is that there's just the distinction between the two. We haven't really hit up on it too much so far in this course. When we say LC-3, we've kind of used that interchangeably to refer to either the architecture or the organization, but they're actually very separate entities. It is possible to implement the LC-3 architecture in a way that's completely different than what's on that last slide we saw, than what's we sort of looked at so far. This is one implementation of the LC-3 architecture, but it's one of many. In fact, when we get to Unit 5, we'll see kind of one variation on this architecture, which still meets the specifications of this architecture kind of design. But in a different way than we sort of analyzed so far, which has some benefits and has some detriments. So if you are in Appendix A, basically you're in this part of the LC-3 called the architecture, which is almost more like an interface. It's a specification which has no implementation just yet, and so just about anything in Appendix A is going to be sort of independent of how the LC-3 is actually built. If you're in Appendix C and we're talking about control signals and state machines and data path elements and stuff like that, then we're firmly into the realm of sort of implementation, and the organization. All right. So an example of this, is the fact that the fact that our instruction includes an add instruction, is part of the architecture. And so, believe it or not, there are multiple ways to potentially implement this type of instruction. When we are talking about the organization and we are referencing the fact that we've got an ALU, with these operations in it, that's part of the organization now. That's an actual implementation detail which we've chosen to sort of use to be able to implement the LC-3 architecture. So kind of similarly, like how if we take a step back and look at the organization and see kind of how this data path is dealt with a complete computer, we might also kind of take a step back and almost take a look at the whole first part of this course here to say, this slide kind of summarizes that, right? The whole first part of the course is to be able to kind of talk a little bit about what computers are, but then also how, what is the architecture that we call the LC-3? How do we define that? What does it mean to have 8 registers and these instructions? And then what is one implementation of that? What's one way to build that architecture in real hardware so that it works like we specify up here? All right, folks, that's all I got. I'll see you next time.